Good morning. So in this video, my hope is try to give you an outline about test 1 questions. You might want to go back and revisit those concepts or take notes or add them in your note sheet, hopefully. I'm not going to be solving questions, but the things that I am going to underline will be definitely important for you. Just to go back once more and look at those or take notes for those concepts. So we're gonna go ahead and have a look with first chapter 1. The most important thing that we learn, one of the most important things that we learn in chapter 1, population versus sample. So you should be able to identify what is population and what is sample, because it will bring you to the next concept, to parameter and statistics. So parameter is a measurement coming from a population. Statistics is a measurement coming from a sample. And it all depends on what's the big idea, what's the research question. For instance, let's say that out of all the Wake Tech students, we interviewed 200 of them, and 25% of them said that online classes are really helpful. So all the Wake Tech students is the population, 200 students that we interview is the sample, and 25% is coming from the sample, so that will be a statistics. What is the parameter? We didn't get any measurements from all the Wake Tech students, so there is no parameter in there. Okay, variable types. Usually students get quite good on it. What is quantitative variable? What is qualitative variable? Or the other words for that, categorical or numerical. All right, categorical and numerical. Just because it has numbers in it, it doesn't mean that it will be numerical or quantitative variables, because when you add those numbers and take a mean or take an average of those numbers, it should make sense, like bank account numbers. I could collect the bank account numbers from the people in my neighborhood, but if I add them up and find an average of it, right, it's not going to provide me any useful information. Okay, that's also some point that you really need to be careful. So sampling techniques. All right, so we are going to collect a sample. There are many ways to do that. One of them is convenience. Usually it's not preferred, but as long as you just put it in your research, that will be okay. It's not like bad thing, but sometimes you need to have convenience sampling because of your time and money restrictions. Simple random sample, students identify it really well. Systematic, every cake, that's okay. However, we usually have difficulties to identify, stratify, and cluster. So stratify is coming from homogenic groups, right? In stratify, we're not dividing the population into regions or into classes. When I do stratify sampling, for instance, I am just dividing the groups, let's say males and females, and I'm randomly sampling from them. That's strata, each one of them. Or I'm dividing the Wake County into their professions, like teachers, doctors, dentists, nurse, librarians, and I'm taking 5 from each strata, right? Cluster, okay, the keyword in the cluster is all right? And you're taking it again from some specified groups, but they're not homogenic. Another example as a difference between strata and cluster could be Boston layer cake. I just learned it years ago from one of the textbooks. So Boston layer has got 7 or 5 layers of cake. Each layer is, let's say, the cake itself, the dough, vanilla and strawberry, chocolate, cream, and the topping part. So each layer is a strata. However, if I take a slice from the cake, after I divide the cake into 4 or 5 equal parts, that will be a cluster, right? Okay, so that's that. Now, types of studies. That's another thing from chapter 1. Especially we want you to be able to differentiate between what's experiment and what's observation. Simulation and survey, usually easy. It can easily, or more easily, can be identified. So experiment, you have a treatment group and you are manipulating the system. You are giving something to some group and you have a control group that you're not giving that treatment. So for instance, an example of it, as a teacher, let's say that I have a theory. If students use dynamic programs in stat classes, they will understand variability better. So in one of my classes, I'm using that dynamic computer program. On the other one, I'm not. And then I'm measuring how their scores change in variability question. So that's an experiment. Observation, again, in my theory, I'm thinking that students do not grasp the idea of variability easily. So I'm just looking at their test scores in both of my classes and I'm recording them on their test scores on the variability questions. So that will be an observation. All right, simulation and survey, it explains itself. I just want to underline that is one of the purposes of this video, experiment design. So first of all, experiment design and a sampling technique are two different things. Okay, sampling technique is the way that you are scooping from your experiment. Experiment design, how you design it. It's something to do a bigger picture. So there are three big designs: completely randomized, randomized block, and match pair. So I want to give an first definition and an example. So completely randomized, you have no subgroup, you're just choosing randomly. There's no subgroup. That's the keyword. No subgroup. Okay. Is it erasing? Yep. Right, there's no subgroup. Randomized block, we are grouping it into subgroups, and then we are taking equal or proportional representation. Match pair, you're pairing them, like pairing the twins, pairing the tires, or before and after of the experiment. So each of them I will try to give an example. For instance, randomized block, right? So we have subjects and we know that gender might play a role. First, we are putting them into two subgroups, women and men, and when we randomly assigning treatments. Okay, so we have three groups there, hence equal. Three groups here, where each group will have a different therapy in men and women. According to gender, we might think that gender play an important role in that therapy, so that's why it's block design, randomized block design. However, if you go with just randomized, completely randomized one, right? So here we going to create a specific control group, and we want to know the results of it. So it's like an experimental control group. We don't know what could be the hidden effects under those group, so we put them in random, like in this fertilizer case, random boxes, and then we make a comparison between the control measurements and the other measurements. Okay, so we did not create those boxes according to any specification that we can foresee. So match pair design, it could be happening like closely matched subjects or data points. It could be sex, height, weight, age, income. Within each pair, we randomly assign a treatment or not. All right, as a summary. So match pair, students over the years of my experience can identify it compared to other two a little bit easier because there's a pair. But blocking and randomize, they might confuse with that. So blocking is something that you want to control the factors that you can see, right? Like gender, age, or grade level, or socioeconomic status, things like that, right? However, randomly, just random, is just help the ones that prevent them that you can't see. There are some factors in it, but you don't know. So you just, that's why giving a group, you have a one control group and one treatment group, and randomly assign the treatments on it. Okay. So there are other things that you might want to check in terms of definition. What is replication? What is control? What is placebo, blinding, and confounding variables? They're all coming from 1.3. All right. So chapter 2. Chapter 2 is about frequency distributions to create frequency histograms. You're not going to be asked to create a frequency histogram and share it with us on the test. However, you might have to create a frequency histogram and talk about it, which I will post it on another video. So what I need you to know with the frequency distributions at this point, do you know what is LCL, lower class limit, and how you measure it? Do you know what is upper class limit and how you measure it? And do you know what class width, how you get this? Okay. And it doesn't matter, you know how to create histograms in Excel or StatCrunch, but StatCrunch gives you an ability to create a histogram easier than Excel. Again, on a second video today, I will show it to you. Just quickly create 2 histograms and compare it. And even box plots, you can see that and compare it. You should be able to interpret the histograms well. This was your assignment 1. Okay, I did not grade it, I'm still working on it, but what we're doing, we're organizing the data, numerical data in a histogram, and because we want to talk about the histogram, we want to talk about the data. All right, there are other ways to look at the data, numerical data, especially stem plots and dot plots. Bar graph, we use it for categorical or let's see, categorical variable. Okay, Pareto chart, pie chart, again for the categorical variable. Okay, so this will be box plot, that's my spelling. And it is in chapter 3, right? We look at that and talk about that when chapter 3 comes. And misleading graphs. Okay, just know some features that identify if the graph might be misleading the reader. All right, chapter 3, mean, median, mode. What's the relationship between mean, median, modes? For instance, if you have a right skewed distribution, it means that the mean will be on the right and median will be on the left, right? Because mean is not resistant for outliers or the data values, whatever ended. So if you have a left skewed distribution, mean will be on the left of median. However, if you do have a bell-shaped distribution, let's put it in a different color, like this one. Okay, so here mean and median is equal. Modes, we usually talk about modes with the categorical variables. However, mode signifies or indicates the highest value in that distribution. So distributions, we want to talk about them first shape. We look at it, then center, and then spread. So distribution is skewed, left or right, it doesn't matter. Then the typical value or center, we would like to use median. If the distribution is skewed, right or left, it doesn't matter. Then we would prefer to use median as a typical value or center. If the distribution has a bell shape, approximately, then we can talk about mean. And spread will be standard deviation. So mean and standard deviation goes hand in hand as center and spread, and median and IQR goes hand in hand as center and spread. And mean and standard deviation is on the bell shape, distribution skewed, right or left, it doesn't matter. We use median as a typical value, with the spread measurement IQR. Okay, there's also another thing, 5-number summary and empirical rule. So empirical rule, the name itself, we need to have a bell-shaped distribution, and it goes with 68% is 1 standard deviations above and below, and 95% 2 standard deviations above and below, and 99.7% 3 standard deviations above and below. Anything above 2 standard deviation or below 2 standard deviation will be unusual. When the spread is does have a bell shape, and because the shape is bell shape, then we can talk about the mean and standard deviation. Then we can use empirical rule. However, if we do have a skew distribution to left or a skew distributions to right, then we want to use the 5-number summary. All right. And in that 5-number summary, know what 5 numbers are. They are minimum Q1, Q2, Q3, and maximum. Minimum Q1, Q2, Q3, and maximum. Hence, mean and standard deviation is not here because we decided to use 5-number summary. The reason we're not using, we should not be talking about mean because the distribution is skewed. All right, so this was a quick recap about chapter 1, 2, 3. Obviously, there are questions that requires your evaluation, finding the z-score, and the other details. Make sure you look at them, but I just wanted to emphasize all of this and try to help you, particularly with the experiment design and what is completely randomized block and match pair. Oftentimes students skip that. It's reading, it's not our best forte. Don't do that. Just make sure you really understand what is completely randomized and randomized block. And hence with one thing, that's the difference. Blocking is used to control the factors that you can see, you can identify it, like gender, age, grade level. Randomization, you're just helping the balance that you cannot see. And there are 2 examples that I have talked here. And match pair, it is easier to identify because look at the picture, you're just looking at twins or sisters or brothers or before and after of a phenomenon. Well, I hope this is helpful. Wait for me for creating histograms in StatCrunch. See you soon.